All right, we're going to start our factoring unit. In your book, this is known as 5.4. It's just one section. In the book, they have all of the problems mixed together, and I'm going to separate them for you. We're going to take them one at a time, and then we'll mix them all up and see if we can tell the difference. Before we do factoring, let's review the distributive property. Now, this should be fairly easy because we've been doing this for several years now. So if we have 5 times a plus 3, distribute 5, and we'll get 5a plus 15. Easy enough. Distribute 2a. Now remember, when you multiply a's, we add their exponents. That's why we get 2a squared minus 8a. Keep going. Distribute. 3 times 3 is 9. A to the third b minus 3a squared b. And finally, we would get negative 4 a to the second b to the second plus 6 a b to the fourth. Now I'm fairly confident that we could get all 4 of these questions correct. Now we'll move on to factoring. So when you look on the other side of the page over here, you'll notice that the problems are looking very similar to the answers we got when we were practicing the distributive property. That's because to factor, the very first thing you want to do is try to take out the greatest common factor. You could also call that undistribute the problem. So we're going to do the problems backwards. Again, our problems are looking like our answers. So now the answers that we get over here will end up looking like these problems that we did over here. So we're going to take out anything that they share or have in common. So if you have 5a minus 10, both of those are divisible by 5. So we will take the 5 out, put it in the front, and when you take out, you're thinking, I want to divide. So if you divide 5a by 5, you get a, and if you take 10 divided by 5, you get 2. You can always check your answer by redistributing and see if you get the original problem. Number 2, what do 12 and 15 have in common? A 3. So we're going to take out a 3. Do they have any letters in common? They both have an A. So we take out 3a. Make a parenthesis and say what's left. And the way you figure out what's left is you divide. So 12 divided by 3 is 4, and a squared divided by a is a. Minus 3 goes into 15 5 times, and a divided by a, then there would not be an a over here. It's just the minus 5. Again, you can redistribute, and you would see that you get 12a squared minus 15a. Number 3, what do 27 and 15 have in common? 3. What letters do they have in common? They both have an A, and they both have a B. So if you take that out, what's left? 27 divided by 3 is 9. One of the A's came out, and the B came out, so you don't have it left. Minus 5. The A came out. There's 2 B's, so you have one of your B's left. Again, you can redistribute to make sure that you're doing it correctly. So if you look at this, you can see that the distributive property going one direction is here, and going the other direction is this factoring problem. All right? So undistributing something is just factoring it. How do you know when you're done? Well, when you look at the parenthesis, you want to make sure nothing is in common between those two terms. Nothing else could be taken out. Nothing else could be taken out. That's how you know when you're done. So that's the first step in any factoring problem, is to ask yourself, can I take anything out of the problem? Now, some problems you won't be able to take out, so you'll go to the second step. Some of the problems, that's all you'll be able to do is take stuff out. But you want to remember to ask yourself that at the beginning of every problem. So that's one kind of problem you'll do in today's homework. All right, let's go back to some review. And we want to remember these special no-middle FOIL problems. Now, you did that worksheet that had a whole bunch of questions on it, so you should be getting pretty good at this. You need to be able to recognize, why are we calling it a no-middle? Well, we have one of them with minus and one of them with plus. That's why we call it a no-middle. And everything else stays the same. So when we say no-middle, we mean that the O and the I cancel each other, so all we need to do is first and last. So you should be able to do these real quick. That would be x squared minus 16, because negative 4 times positive 4 is negative 16. Here we would get 4x squared. Positive times a negative is a negative. 3 times 3 is 9y squared. It doesn't matter that the x is in the back. You still do first minus last. You get 16 minus 9x squared. So we should be pretty good at these. Again, now we're going to look over here into the factoring column. And what you should notice is all of these problems look exactly like all of these answers. So you're going to tell me what this was before it was FOILed. Well, what you should notice is that none of these have a middle term. So they were all no middle problems. The first term is a squared number and a square letter. So everything's square. The last one is also something that's squared. So if you look at those are all really nice numbers. All right? Same thing over here. All these were really nice squared numbers, and all the signs are minus. It's important that they are a minus sign. The only way we're going to get a minus sign is if we have one of them with minus, one of them with plus. Now you can continue to call these no middles, okay? So because these don't have a middle, okay? So you could think these are called no middles. Another way to think about it is square minus a square. So a square term minus a square term. It only works if it has a minus sign. If there's a plus sign there, you will not be able to factor it. Again, if you check these answers, you always get a minus sign. So we have to have the minus sign. So if it's x squared minus 25, you're like, oh, there's no middle. So one of my parentheses needs a plus and one of them needs a minus. How do you get x squared? X times x. And how do you get 25? 5 times 5. No middle. 4x squared minus 49. It's a square minus a square. One of the parentheses is going to have plus, and one of them will have minus. Now just decide, what do you need to put in there? How do you get 4x squared? 2x times 2x. How do you get 49? 7 times 7. Now it's just a habit of mine. I always put the positive term first. You'll see why later. Don't worry about this being backwards. People want to switch that around. You can't switch that around. There's a minus sign here. Again, it's a square minus a square. One of them with plus, one of them with minus. How do you get 100? 10 times 10. How do you get x squared? X and x. Now just like above, how do you know when you're done? Well, can you take anything out between these two numbers? They don't have anything in common. Are they square minus squares? Well, this isn't even a minus sign, so that doesn't matter. This is a minus sign, but are these square terms? No. That's how you know you're done. And you're going to want to start checking that, because as the problems get harder, you want to make sure you're checking that. Now this last one is a little bit tricky. A lot of people want to tell me that the answer is 2x minus 10 and 2x plus 10, because that would follow this pattern that we were doing. The problem here is we did not take out, therefore these are not factored all the way. Most people will not check that at the end. So at this point you could say, well, take the 2 out and you'll get x minus 5. Take the 2 out and you'll get x plus 5. Put this 2 up front and you'll get 4 x minus 5 times x plus 5. And that works. Okay, that works perfectly fine. It might be easier, however, if the first step is always take out. The second step will be, I like to draw the picture, a square minus a square. Okay? So that's our first step, and that's our second step. So you could see here 4 and 100, you could take the 4 out and get x squared minus 25. And now you notice that that's a square minus a square, so you get x plus 5, x minus 5. So you can do it either way because those are equal to each other. I can just promise you that most people who do it this way will forget to then take that 2 out of both parentheses. So most people will do it this way. It makes no difference.